Exactly. It doesn't matter how you denote them. You want to denote this by C, this by A, and this by B? That's fine. C squared equals A squared plus B squared. Denote them the way you like. It's not a problem. As long as you always write the hypotenuse squared is the sum of the two legs squared, that's fine. Yep. So now remember what we wrote. We wrote that the square root of x squared is 4 the square root of 10, right? And then we wrote that x equals the absolute value for the square root of 10. And then we wrote that x equals actually plus or minus 4 the square root of 10. This principle of taking square roots allows us to omit this. But I don't want you to think that if you have this equation, you take the square root and you write x equals plus or minus 2, I don't want you to think that the square root of 4 is plus or minus 2, because that's incorrect. Where do the plus or minus come from? From the absolute value, not from this side, right? So please do not consider that the square root of 4 is plus or minus 2. That would be incorrect. So in general, the taking square root principle, so if I have x squared equals k, a number, positive or negative, when I take the square root, I immediately write x equals plus or minus the square root of k. But remember, there is an intermediate step. I omitted the fact that this is the case. So in between these two, I should always write this. We don't. We start here and we end up here. But we know that there is an intermediate step in there. And that's the intermediate step because the absolute value creates the plus or minus, not the square root of k. Very good. Okay, so let's look at 55. In 55, we have this. We're given another right triangle with one leg, which is 9 meters, and a hypotenuse, which is 11 the square root of 5 meters, and we're asked to find another leg. So let's work on this for 1 minute, and then we'll look at a word problem. Remember, the notation is not important as long as you write the correct sequence. The hypotenuse squared equals the sum of the legs squared. Can anyone get us started? Yes? Yes? So you can write it like this first, and then think about it. So this is 81 plus x squared. What about the right-hand side? Exactly. I have to square 11, which is 121, and I have to square the square root of 5, which is 5. What do you mean by not to do them individually? This is not a sum. These are not terms. These are factors. So when I talk about 2 plus 3, I talk about terms. But if I talk about 2 times 3, I'll talk about factors. I can, when I square factors, I have to square individually. But when I add terms, I cannot square individually. So then x squared equals, I got 605 minus 81. So then x squared equals 524. What do I do now? I take the square root from both sides. And remember, there is an intermediate step that I skip, but I have to remember this. So what did you get 524 split into? 4 times? How much? 131. So that would be 2 times the square root of 131. Obviously, only x equals positive 2 the square root of 131, which is in meters. You can approximate it if you want to. Where's my calculator? I have it here, I think. Oh, yes, I do. So you can approximate it. You can always approximate if it's when it talks we talk about a distance or a length or yeah. So 2 times the square root of 131. I got approximately 22.9 meters. Is that okay? Okay. Okay. Please.
How do you get 2 times the square root of 131?
524, you start with the fact that it's an even number, so it's divisible by 2. So, and then I get 162. And then you continue. No, I get 2. I'm sorry. 2, 4, 6, 2. And then you see it's an even number, so you divide again by 2 and you get 131.
So you're just factoring and then...
Factor using prime factors only. Yes. So then you have that the square root of 524 is the square root of 4 times the square root of 131. And the square root of 4 is 2 and 131. Better?
Yes.
Perfect. Anything else? Other questions here? Yes, please, John. It's a very good question. If there is no information, I would write hundreds. Tens is good enough because we're talking about meters here. It's a very good question. If you want 2 decimal digits, you can. For this particular example, I'll write just 22.9. Yeah. Okay, so let's look at a word problem like 61. On page 631. A spotlight is mounted on the eaves of a house, 12 feet above the ground. So we are given this picture, and here's the spotlight up there, and it's 12 feet above the ground. A flower bed runs between the house and the sidewalk. So the closest a ladder can be placed to the house is 5 feet. And this is the ladder right here. How long of a ladder is needed so that an electrician can reach the place where the light is mounted? Yes. Or x squared equals 12 squared plus 5 squared. The hypotenuse squared equals the sum of the 2 legs squared. So then x squared equals 144 plus 25, or x squared equals 169. And of course, we will take the square root from both sides. Of course, we know we omit a step, but it's plus or minus 13, and that's feet. We'll say only, of course, x equals 13 feet. Any questions? You mean this one? We have to take the square root from both sides. Is that okay? Any questions? The last section of this chapter is section 10.7. It deals with complex numbers. Okay, what is a complex number, first of all? A complex number has 3 pieces. It has a real part, and an imaginary part. This is a real number. And this is called the imaginary unit. And now the obvious question should be, don't we have enough numbers? Do we really want to talk about complex numbers or imaginary unit? Isn't this enough? Okay, here's the reason why we needed complex numbers. So let's suppose I want to solve the equation x squared equals 4. What would you, x squared plus 4 equals 0. What would you tell me to do first? Good. But then this is a contradiction for real numbers. Why is this a contradiction for real numbers? No. It's because this part is always what type of number? Positive. And this number is. So I am telling you that a positive number equals a negative number. Would you accept that? No, you can't accept that. So bear with me, and now let's take the square root. So we have x squared equals negative 4. We know it's a contradiction for real numbers. So when I take the square root, I will have x. Remember the step I skip, which is plus or minus. But now this side, the square root of negative 4 equals the square root of negative 1, as we know from this chapter, times the square root of 4. The square root of 4 I know. 2. Exactly. And this, we denoted it by I. So the imaginary unit that we discussed previously is the square root of negative 1. So that's why we will write 2i. So in this chapter, we will learn a few things. Number 1, how to add, subtract, multiply, and divide complex numbers. And then how to raise I to a particular power. So that's one topic. And the second topic, I to any power. Okay. So can anyone give us an example of a complex number? I'll give you the first one. Let's say negative 3 plus 4i. This is an example of a complex number. And can anyone give us another example so we can add, subtract, multiply, and divide them? Negative 8 minus 2i. Okay, very good. Before we attempt to add, subtract, multiply, and divide complex numbers, I want to draw your attention to one thing. What did we say I was equal to? Careful. Square root of negative 1. Please square both sides and tell me what you get. Indeed. So I is the square root of negative 1. We know that I cannot be a real number. And when I square both sides, I squared is negative 1, which we know, again, this happens only under a different umbrella called complex numbers, not under real numbers. Now, one more thing. Can I write any real number as a complex number? So in other words, I'm asking, the real number set, is it bigger or smaller than complex number? Bigger, because I can write any real number as an imaginary number, like 10 equals 10 plus 0i. Okay, and so on and so forth. So therefore, complex numbers, so these are complex numbers, and the real numbers are inside. Okay? So we have two complex numbers. We want to add, subtract, multiply, and divide them. So let's start by adding them. Negative 3 plus 4i added to negative 8 minus 2i. I don't need to put parentheses, but I just want to make a point. So this is how we add two complex numbers.
Plus 2i versus minus 2i.
It's minus 2i and minus 2i. So then negative 3 plus 4i minus 8 minus 2i, all I have to do is combine like terms. So let's combine like terms. What will you tell me to write? And the order has to be the real part plus the imaginary part. That's it. Now let's subtract these two. Negative 3 plus 4i minus negative 8 minus 2i. Negative 3 plus 4i, and then
Plus 8 plus 2.
very good, we have to change the signs. Again, the real part plus the imaginary part. 5 plus 6i. Very good. Any questions? So it's just combining like terms. I didn't do anything, right? Now, let's take the same two numbers and multiply them. Let me ask you if you have any questions so far, please. Any questions? Any questions? Okay, so please dictate. What should I write?
Plus 6 minus 32i minus 8i squared.
Very good. Now, what do we know about I squared? I squared is negative 1. So I will have 24, but plus 8. 24 plus 8. And now I combine like terms, and I get good. So then the final answer is this. Let's look at the product one more time and make sure that this is clear. Any questions? Yes, of course, sorry. Any questions on the product? Any questions on the product? Anyone? Yes, yes, please.
So the negative 8i squared, so the I squared is separate from the negative 8.
What is the operation between negative 8 and I squared?
Sorry.
What is the operation between negative 8 and I squared? If I say 4x, what is the operation between 4 and x? Perfect. So the same thing we have between negative 8 and I squared. So when I replace I squared by negative 1, all I have to do is multiply negative 1 by negative 8, and that's how I get the positive 8. Better? Good. Anything else?
So I thought that you were just going to multiply each thing. Like, I thought you were just going to multiply.
You're talking about this?
Yeah.
So this is a binomial, and this is another binomial. I have to FOIL. This times this is this. This times this is this. This times this is this, and this times this is this. Is that okay?
Yeah.
So then I squared was changed, replaced by negative 1, and I got 24 plus 8, and then I combine these two because they are like terms into negative 26i. Is this better? Everyone? Okay. So now let's talk about division. Addition, subtraction, multiplication are kind of straightforward, I would say. But division is not that straightforward in a way, if you want. Which one would you like to divide by? Because we have these two. You choose which one you want to divide by. In the numerator? Okay. Negative 3 plus 4i and negative 8 minus 2i.
Negative j is 7i starting.
Okay. Do you remember how we rationalized, and we had a problem like this on the quiz? The square root of x plus the square root of y. What did we rationalize it by? Right? Exactly. The same thing here. It's the same idea, the same principle. And I'll explain why in a minute. Maybe I should explain now. So whenever we multiply a plus bi by its conjugate, which is,
A minus the other.
we will always get a real number. And that's what we want. We want the denominator to become a real number, not a complex number, and then we're done with division. So please remember to use the formula and tell me what should I write. We use this formula for rationalizing everything. A squared, it has to be minus, right? It has to be b squared, and it has to be I squared. First term squared minus the second term squared. So then I know what the I squared equals to. I squared. I squared. Negative 1. Negative b squared times negative 1 is plus b squared. So that's the reason why we need to multiply and divide by the conjugate of the denominator. Because the result, when I multiply these two, I will get a real number in the denominator. So what is the conjugate of negative 8 minus 2i? Exactly. Negative 8 plus 2i, negative 8 plus 2i. So now, the denominator. We already have the denominator because we know how to multiply two conjugates. First term squared minus second term squared. And I know that I squared is. So eventually I will write in the denominator, when I'm done, I will write 4 plus 4, which is good. But now I have to come back to the numerator because I have to FOIL it. I have no choice. Negative 3 times negative 8. Negative 3 times positive 2i. 4i times negative 8. And 4i times 2i. I have to replace I squared by. So then I will have 24 but minus 8. 24 but it's minus 8, and I can combine these into negative 38i. 24 minus 8. 16 minus 38i over 68. I have to separate it into 16 over 68. Oops. 16 over 68 and minus 38 over 68i. And I have to simplify both fractions as much as I can. 16 and 68. 68, if I divide it by 2, I'll get 34. If I divide it by 4, okay, so 16 divided by 4 is 4. And this divided by 4 is 17. So 4 divided by 17 minus 38 and 68 by 2, and the top will be 19 and the bottom will be 34. This is the final form, where this is the real part and this is the imaginary part. A lot of work with division of complex numbers. Any questions for me?
We do know numbers.
Sure, just choose any division of two complex numbers. Make up two complex numbers to divide. Division you meant, right? Okay, anything. And then I would like to look at a few other examples from the book.
Examples of division.
Okay, so 73 on page 640, and in which we have 2 minus 3i over 2 plus I. We need to multiply and divide by the conjugate of the denominator, which is 2 minus I over 2 minus I. The denominator is First term squared.
minus
Very good. But I squared is
-1.
perfect. So the denominator will be 5. Excellent. Now I have to multiply the two numerators. And I have to use FOIL. 4
minus 2i
minus 6i
plus 3i squared.
Very good. But I squared again will be replaced by -1. So I will have a 4 minus a 3.
So
1 minus 8i. And I have to split it, and there is nothing else I can do here. But I have to split it and show the a plus bi. I have 4 more minutes, and I would like to show you powers of I. No, I will not, but this is how we have to present it. Yeah. Give me a power of I, any power you can think of. Which one? What about 2016? Okay? Remember, I only have two things. I only know that I is the square root of -1, and I know that I squared is, that's it. That's all I have, basically. So now I know that there is a way of rewriting this, because 2016 is an even number, as I squared raised to a power. Can anyone give us that power? What power do I raise I squared to get I to 2016? 1008. One more time. How much is I squared? And how much -1 to 1008 would be, since the power is even and I raise -1? It's 1. Give me another power. 2684. Okay, will be very similar because you also picked an even number, but that's okay. So this will be I squared raised to which power? It's similar, but maybe the result will be different. I'll show you. So 1, 3, 4, 2. Okay, so this is -1 to 1342, which is 1. Okay, now allow me to choose I to 313. Well, 313 is not divisible by 2, so I have to split it into I to 312 times I. Is I to 312 times I the same thing with I to 313? Good. Now I can work on the first one and write I squared to some power, but the other I has to stay. What power will that be? $156? Good. So then I have -1 to I56 times I. But how much is -1 to I56? How much is 1 times I? So I to any power you want has only 4 possibilities. We only hit 2 of those. We'll look at the other ones on Wednesday. 2 on Wednesday. -1, 1i, or I and -i. These are all possible options. I to any power can be only -1, 1i, or -i.